Okay, in the following video, we are going to be looking at volumes of solids of revolution. So that may mean nothing to you right now, but I'm going to want you to try to visualize these things. You're going to have to visualize in 3 dimensions at this point. So what we're going to do is we're going to, in this first example, use a method called the disk method to find the volume. So let's see what we're talking about here. So I've got a graph here, and I'm going to graph the 2 functions. First one is y equals the square root of x, and so let's just say it looks something like this. And then we're going to graph y equals 0. Well, y equals 0 is just a horizontal line like this. Okay, now if you can imagine, all right, you're going to rotate this about the x-axis. So we're going to rotate it this way. Okay, so if you can picture that, all right, I'm going to try to draw my best sketch of this. All right, and what we're going to do is, if you think about this, it's rotating. Maybe it kind of looks kind of like an acorn, or maybe like a top or something like that. What we're doing here is we're rotating it, and it's forming a 3-dimensional object. And so what we're going to do is we are going to cut out a disk. And so what does that disk look like? So I'm going to kind of try my best to draw a disk. And let's see if you can see it. Okay. Okay, so there's my disk, if you can. What we're going to do, and let's see if I can extrapolate the disk. Okay, so the disk, it's like a, if you think about it, it's like a coin, if you will, and that's what we're slicing. We're going to find the volume of a disk. Well, think about it this way. This is a circle, all right, and it's got a thickness. Okay, so it's got a thickness that we're going to call dx. So if you look at the formula up here, it's basically pi r squared dx. Well, this right here, this thickness is our dx, right? And then this right here represents the pi r squared. Okay, and I'm going to put capital R, pi r squared. So you're going to take basically the area of the circle, multiply it by the thickness dx. And when we integrate that, in this case from 0 to 9, so this is 0, and let's say that this right here is 9, okay, 9 right there. What we're going to do is we're going to find the volume of all of these little disks along the way. Okay, so that's where we're going with this. All right, so it's nothing terribly difficult. What we're going to do is we're going to integrate using the function. So let's figure this out for a second. What exactly is the radius? Well, the radius is represented by the difference between the 2 functions. So this right here is our r of x. But in this case, it's going to be the square root of x minus, in this case, 0, which is just the square root of x. Okay, so if it were, suppose y equal 1, then you'd say, well, square root of x minus 1, for example. But in this case, it's just the square root of x. Okay, and so again, the thickness is just represented by dx. So what we're going to do here, very simple, we're going to integrate this function to find the volume. And we're going to integrate it from 0 to 9. Okay, and we of course have pi. Now our r of x function is this square root of x minus 0, which we're just going to leave as square root of x and square it, and then multiplied by the thickness dx. And so we can simplify this just a little bit, and I'm going to move the pi outside. Okay, and I'm going to have square root of x squared, which is x. Okay, let me fix that a little bit. X dx. And then again from 0 to 9. So then when we integrate that, we're going to get x squared over 2. Okay, we get x squared over 2. And again, we're going to have the pi on the outside. And then we're going to evaluate it from 0 to 9. And so when we do this, we're going to have pi. We're going to have 9 squared over 2 minus basically 0, because plugging in 0 will yield 0. So then we end up with something like 81 over 2, then multiplied by pi. So there is our answer for our volume. And this is in cubic units, of course, but I'm not going to write any kind of units because we really don't know. But let's just call it cubic units, okay, or units cubed. but this is our volume, and this is how we do it, and it's actually really neat application of integration. So hopefully this was a good example for you, and we're going to take a look at another example next using something called the washer method. So stay tuned for that one. Okay, now in the next example, we're going to be talking about something called the washer method. And before I explain the formula, let me just show you what the graph of this would look like, and then we'll go from there. So again, we're still revolving or rotating about the x-axis. So let's go ahead and take a look at the graphs here. The first one is x squared plus 2. And so this one is parabola. It's shifted up 2 units. And we are going to, let me fix that, adjust that a little bit. I don't know how it jumped. Okay, let's see. It looks something like this. Okay, looks something like that. Maybe that's not the best picture there. And then the other graph is 4x plus 2, so it's also cuts through that same spot. Okay, and actually I'm going to do a better job at graphing this. Let's see if we can pretend that it's really zoomed here. There's that one, and then I'm going to draw the other one in green. And let's say that it looks something like this. Okay, so I'm actually only going to look at one side of this because we are only concerned with where, number one, it intersects. And it intersects here at this spot and here at this spot. And I'll actually tell you what those points are. This point right here is the point 0, 2. And then this one right here is the point 4, 18. Okay, and so what we're doing is, again, we are rotating it about the x-axis right there. And let's see, if you wanted to visualize it, okay, it's going to look maybe something like this. Okay, something like that. And then here's the green one. Something like that. Okay. So we're looking at this, and I'm going to kind of highlight in here so you can kind of see what we're looking at. And I want you to see that if we were to extrapolate something from here, and let's just, say we're going to slice it right about here. Okay. Well, I want you to see that it's actually hollow in the center. So if you think about it, okay, so let's say it's something like that. Kind of looks like a donut, if you will. All right, but it's also got this thickness dx, okay? But notice it's hollow in the center, and that center, it just grows as the function goes from 0, in this case, to 4. And so what we're doing is, if you think about the last example of the disk method, it was kind of like a cylinder, if you will. This is the same concept of that kind of cylinder or disk, but we've got to subtract the volume of the inner part, okay? That hollow area in the center. So this is where the formula for this one is similar yet different, and that is to say that the capital R of X here represents what we call the outer radius, okay, and the small r of x, the lowercase, represents what we call the inner radius. Okay, so what we're going to do is we're going to look at these two functions, and I'm going to tell you that the one on the top, the outer, will be represented by 4x plus 2, and the inner radius will be represented by y equal x squared plus 2. Okay, and so we've got that right there. And let's see what we've got here. We're going to integrate pi, and we're going to go from 0 in this case to 4 because those are the intersection points there. The outer radius, again, represented by 4x plus 2, and we're going to quantity square that. We're going to subtract x squared plus 2, and we're going to quantity square that. And then we multiply by dx. Okay, so the first part of this is really just a bunch of algebra. So what I'm going to first do is I'm going to factor out this pi. Again, we're going from 0 to 4. And we're going to do the binomial square. So let's write out that binomial square trick here. And I'm going to write it out to the side. the binomial square. And I've gone over this many times in previous videos and in my classes. It's a squared plus 2ab plus b squared. So keep that in mind because I'm going to kind of zoom through this. All right. So let's see what it looks like. All right. When we do the first binomial expansion, we're going to get 16x squared plus 16x plus 4. And again, that's the binomial square. We're going to subtract. And in this case, it's x to the 4th plus 4x squared plus 4. And then again, all of this gets multiplied by this dx thickness. Okay, and so now it's just kind of a matter of doing the distribution there of that negative sign. And let's go ahead and scoot this up a little bit. All right, again, pi on the outside from 0 to 4. 16x squared plus 16x plus 4 minus x to the 4th minus 4x squared minus 4 dx, and we're going to combine like terms here, and let's see what we've got. I know we've got this 16x squared here with a minus 4x squared, and then the next thing is the 4 here and the negative 4. Those will cancel out, so then I am left with my pi on the outside, 0 to 4. Let's say it's negative x to the 4th. 16x squared minus 4x squared is 12x squared. So 12x squared there. And the 16x, nothing to combine with. But the 4's do cancel. And so then I've got my dx. And now I'm ready to integrate. And it's just a power rule integral. It's actually really nice. So let's go ahead and do that. We've got the pi on the outside again. We've got a negative x to the 5th over 5. Plus 12x cubed over 3, which we're going to simplify in a minute, and 16x squared over 2, which also gets simplified, and we're going to evaluate this from 0 to 4. The nice part about this is that when we plug in 0, we're going to get 0 for everything, so we really only need to concern ourselves with plugging in 4, and then we'll have our answer. And so what does that look like? Pi again there. We're going to have a negative 4 to the 5th power over 5. Plus 4, right? 12 divided by 3 is 4 times, not 5, 4 times 4 to the 3rd power plus 16 over 2 is 8 times 4 to the 2nd. Okay, and then of course we're going to subtract 0 from all of that. And let's see what we get. Pi again on the outside. And let's see, this negative 4 to the 5th becomes a negative 1024 over 5. 4 cubed times 4, that's 256. 4 squared, 16 times 8, that's 128. And again, we're going to disregard the 0 now. Then it's just a matter of kind of adding fractions and then multiplying by pi. So I'll leave you to that, but you get something like this, 896 over 5. Pi, and that right there is in cubic units. This is the volume of that solid that's generated. So if you think about it, it's kind of like this hollow center, maybe kind of like a bowl, if you will, with some thickness on the inside. But you've got to use this what's called washer method in order to figure out how to find the volume of the solid generated. So again, it's got a hollow center, hence the necessity for the washer method. So as always, I hope this video was helpful. And if it was, remember, like and subscribe.